I'm here today to talk to you about Physics A-Level and why it's such a great A-Level to take. So I'll just put up my PowerPoint. The teachers that we have for A-Level Physics are Mr. Smith, Mrs. Williams, myself and Mr. Cuthbert, who I'm sure you know all of us. So why study physics? For me, the reason that I studied it, and I still love it to this day, is because it explains the world that I live in. It explains things like why kettles are shiny, why the sky is blue, why plugs have earth wires, and so many other things about that we meet in everyday life. Also, in physics, we study things from the very, very largest galaxies to the tiniest particles that atoms are made up of. Physicists are problem solvers, so if you like a topic that isn't loads of writing, but much more to do with reasoning and calculations, physics is definitely the A-level for you. Also, it's very highly regarded, and it also leads on to lots of other things in the future. Some of the careers that you could take with physics are finance, medicine, engineering, programming or computer science, and astronomy, as well as loads and loads more. So I interviewed a couple of my A-level students, and this is what they think about A-level physics.
Hi, I'm Joseph Caldwell, and I take physics, maths and biomatics at A-level. I really enjoy the A-level physics course because it gets to do lots of fun practical. And in my first year, I got the chance to go to Switzerland to see the Large Hadron Collider at Cern. I really enjoy physics because it has real-world applications and it just makes sense in my head. I want to take engineering at university, which leads on very nicely from physics.
Hi, I'm Meadow. I'm taking maths, maths and physics at A-level. I really recommend taking physics if you're thinking of doing a STEM-based subject at university, as physics ties in really well with all the other sciences and especially maths. Some of the topics in maths are literally exactly the same as the ones you do in physics, so I definitely recommend it for taking maths. Another benefit to taking physics A-level is you get a chance to go to Switzerland and go to Cern and see the Large Hadron Collider, which I really recommend doing. It was a trip of a lifetime, I think. It was a great time with all your friends as well. So definitely, I recommend taking physics A-level.
Hi, I'm Joseph Caldwell.
So what would you need to know to be able to do physics A-level? You need a minimum grade 6 in both core and additional science, and also a 6 in maths, because there's a lot of maths in physics, so you need to be capable at doing GCSE maths. You need to be able to communicate effectively, be logical, be good at practical skills, be organised. This is true of all A-levels, not just physics. Motivated and have determination, because you'll need it for all A-levels. You do need to do a lot of work and stick at problems when you come across them. So what sort of a student do you need to be? You need to be interested in physics, so don't pick an A-level that you aren't interested in doing, because you'll be spending a lot of time doing it. You need to enjoy problem solving. It really helps if you like sort of thinking about the world around you and about how it works. You know, things from, I don't know, black holes and all sorts of fascinating things like that. Yeah, I think that's it for this slide. So this is what the courses are made up of. Initially, there's practical skills. So this really just explains to you how to write up experiments. The next bit is just to do with how you deal with data. So units, how to sort of analyze the data you've got, sort of check for errors, see how accurate work out how accurate your data is from the experiment that you've done. Then we've got a sort of a mechanics topic you do next. This is all in the first year for the AS part. we do about motion and vectors and projectiles. And if you're lucky, you can play with the Nerf guns, and I'll show you a little video about the students playing with those a bit later on. Then we get on to, here we do an electricity topic, where it's much more detailed and goes in much more depth than for GCSE. For the waves, we use the laser to work out the wavelength of light. We then get on to quantum physics, where you learn about all the tiny particles, quarks and things like that, and about the wave and particle nature of light. Then these topics are now the A2 topics. Thermal physics, that's to do with the gas laws. We've got astrophysics, which is absolutely fascinating, to do with stars and working out distances. And oscillations, this is to do with things like just how to use with cars and how they have springs and how that sort of keeps the car so it doesn't bounce too much. And there's some quite fun practicals here with circular motion and waves as well, because you use the laser there. And then the last topic, right at the very, very end, we've got here, there's a little video I'm going to show you where we can make our own capacitor. We use transformers. We've got nuclear physics, where we learn about fission and fusion, and medical physics, where we learn about things, all sorts of medical physics, and also PET scans, which antimatter comes into that. The exams that you have, there are 3. The first one is the sort of mechanics, and then what's called Newtonian world, which is a little bit with the circular motion, is the first exam, which is just over 2 hours. The second one is the one where you've got the circuits and the electric fields topics and medical physics. And then the last paper is bits of everything, and it's a bit more complicated. They also have in this one questions to do with checking experiments are okay, and the concept called uncertainty, which is to do with how accurate your experiment was. And then there's also a practical endorsement, which isn't examined. Nobody fails this, because if you miss a practical, or if you haven't done it well enough, you do it again till you do it well enough. And so everybody passes the practical endorsement. So those are the 4 parts to do with the exams. This is just showing you some of the careers that you can go on to with a physics, either A-level or a physics degree. So you can see there's loads of different things that you can do. We normally have around 20 students a year taught in 1 or 2 sets. For the first year, you have 8 hours of teaching a fortnight, and in the second year, you have 9. So there's plenty of time to get through the course really, really thoroughly, and so you have a really full understanding. We have a minimum of 12 core practicals that you do, because there's certain skills you've got to achieve. So there's a minimum of 12, but we actually do more than that. These are to show you some of the practicals we do. This is the transformers, so you can work out the frequency with the oscilloscopes, and you'll learn how to use oscilloscopes, how to set them up, and how to actually use them and take measurements from them. This here, you work out what the value of the acceleration due to gravity is. We do an experiment to do that. This here, you work out something called Young's modulus, so you see how far y will stretch before it breaks. This is the laser, where you can actually work out the wavelength of the light from the laser. This, I think you may well have done before anyway. This is Boyle's law, which is to do with pressure and volume, the gas laws. This one here is a really, really nice little one, and those of you who are musicians will appreciate this. You can work out the wavelength or the speed of sound by having sound waves going into a tube. You use a tuning fork for that. This is quite a fun practical to do with circular motion. And this here, a bit hard to see from the picture, but you can actually sort of work out the wavelength of microwaves, because this is emitting microwaves there, and then this is picking up the signals. So we look at polarization of microwaves and reflection of them. And so this is just showing you a couple of the practicals that we do.
And what I'm hoping can happen is that I'll charge it up, but with all capacitors, if the voltage is really, really high, the insulation actually breaks down, and then you actually, the current will flow between the two capacitors, and you get it discharges really, really fast. You get a spark, so I'm hoping that's going to happen. So now, I've got up to my 5,000 volts, really, really high voltage, so I can't go anywhere near it, and the insulation is breaking down, and you can see there are sparks where it's really very high sort of voltage. Makes a difference producing the current now.
So this practical is looking at the best angle to shoot a projectile to get it to travel the furthest. And it went all the way down the corridor when we got the angle just right. And we're being very coronavirus conscious, wearing our masks. So physics, I think, is an incredibly useful A-level to do, and it's a really, really interesting subject. So as final thoughts then, it's a very, very powerful A-level to have. As with all A-levels, there will be times when you probably think it's getting a little bit tough. You need to ask for help straight away, because we are here to help you, and we will. And if you're a person who's up to a challenge and enjoy working hard, physics is the subject for you. This here is just showing you a couple of pictures of the trip to Cern that I went on a few years ago. This here is a picture of the control room for the Atlas Detector. The Cern, it's where they fire protons at really, really high speed together. They've got this very, very large accelerator, and they fire protons at each other at really, really high speeds, almost the speed of light. And then they see what other particles are formed. And this, they have these detectors, and one of the detectors is called the Atlas. And this is the control room for the Atlas Detector. And this is to show you that antimatter is real. It is not science fiction. And this is where they actually make some antimatter. So we all survived it. We didn't vanish. And this here, there's like a little school or a lab they have where you can make a detector, something called a cloud chamber. And with that, you can detect the ionizing particles that come from the sun and that go through the atmosphere. So that is the end of my presentation. And hopefully I will have lots of people interested in doing Physics A-level.